Hello guys, welcome to another episode of our Python for Artificial Intelligence playlist. So in this episode we are going to be looking at numbers. Numbers in Python, the different types of numbers we have in Python, and some built-in functions we can use to perform calculations and do stuff with numbers in Python. So in Python there are three types of numbers. The first being integers which are of the type int. So if we were to check the type of an integer value, we'll get int, which indicates the type, like integers. So integers are positive or negative whole numbers. Positive or negative whole numbers. So for example, we could have a variable that holds an integer, let's say 23h, or we could have another one, let's say result was to negative 30. They are both integers. They are positive or negative whole numbers. The next type of number we have in Python are float. These are floating point numbers. That is numbers with decimal places. Numbers with decimal places are referred to as floating point numbers. They can be positive or negative, but as long as they have decimal places, they are floating. They fall under floating point numbers, and they are of the type float, F-L-O-A-T. So let's say we have a variable, let's say length, and it is 2.5. so that's a floating point value. The third type of number we have in Python is complex numbers. These are numbers of the form a plus bj. They are numbers of that structure. We are not going to look at them. We are just going to look at integers and floats and methods we can use with them. So talking about integers and floats, the first method we are going to look at when working with them, we are going to look at like the absolute, how we can get the absolute value of a number. So we are going to look at the abs function. So abs like so, a b s. So the abs function is a built-in function that returns the absolute value of a number, and the absolute value of a number is a positive version of that number. So a number can be positive or negative, but the absolute value of a number always returns the positive version of that number. So there are use cases where this can be there are cases where this can be useful. We are not going to look at that for now. We are just looking at like some of these functions. So like the absolute value can be likened to like the same in mathematics, where to get it, you like the absolute value often need to like square a number, knowing okay, if a number is whether negative or positive, once we square the number, the result will always be a positive number. And then when we get the square root of that squared number, we get the initial number, but in a positive, like being positive, which means if we started with a negative number, we always get back a positive number after performing after getting the absolute value. If we started with a positive number, it's the same outcome. So if we were to try to, we are not going to create new variables, we are just going to use print to just see how some of these built-in functions work. So if we're trying to get the absolute value, all we have to do is just call the abs function and pass in the variable we are trying to get the absolute value of. So we can clearly see result, for example, is negative 30, but if we were to pass it through the abs function, it will return to us the absolute value of result, which is 30 itself. So if we do this and we run it on our command prompt, we get 30. Meanwhile result is negative 30. So that's absolute value. That's the abs function. So the next one we are going to be looking at is still like it's still just like the abs function, but it's fabs like so, FABS, and it's still exactly like the abs function, but the only difference being that it returns a floating point value. That means it returns the positive version of a number, but with floating point. That means with decimal places. So for example, we just saw that for when we get the abs of result, which was negative 30, we get 30, just 30. But if we do it for fabs, we now get a floating point result. And one thing I would like to mention is that for fabs we need to bring it, we need to import it from the math library, in Python. So the math library in Python has many built-in functions, mathematic functions like that we can use for different math calculations. So we are going to import math. For now, let's just use it like this. Let's just understand, okay, we import math to get to pull certain functions from. Down the line we are going to see what it takes to maybe have a library, whether built-in or a library we added, and what it takes to import functions from it. So if we're trying to get the fabs of result, what we have to do is we say math.fabs. That's how we use it, and we pass the variable we want to get the fabs of. So in this case we want it for result. We know previously we are printing, okay, let's just comment this out so that we can see just the last result that is we are checking for. So now we see previously we got 30, but now we are getting 30.0. So it returns the absolute value but with decimal places. That means as a floating point number. So this f in front of it is almost like indicating to us, okay, still the absolute function, but that returns a floating point number. So that's fabs. So the next built-in function we are going to be looking at, there are so many, like if we were to say math dot, you see we get arcos, rsine, artan, like seal. There are so many, we are not going to look at them. I'm going to add a link in the description. One you can use to check all the different ones and how to use them, but we are just going to look at a few in this video. The next built-in function we are going to be looking at is seal. Seal written like so. Seal, so almost like sealing. So seal, which is a built-in function that always returns the smallest integer that is not less than the number we like. For example, if we had a number, let's say we have a number x, and we want to get a seal of x. The seal of x is the smallest integer that is either greater than x or equal to x. So when working with the seal function, if x is a floating point number, then it's always going to round up. It's always going to round up to the next integer, But if x is an integer from the start, it is just going to return x. So seal always rounds up if it is working with a floating point number, or returns the same number if it is an integer. So the seal function returns an integer that is greater than or equal to the number we are dealing with. So for example, if we using the seal function, if we wanted to check the seal of, for example, we have length there which is 2.5. okay, 2.5. let's change it to 2.2. normally when rounding up rounding up, the rules in rounding up, like most of the time, rounding up often depends on whether after the decimal place, depending on where the point at which we are trying to round up, whether the number there is greater than or less than 5, which would depend whether we round up or we round down. But the seal function, the seal built-in function, always rounds up. So if we're trying to get, for example, we have length here which is 2.2, which by now, if we're just rounding up, the tendency is it will be rounded down to 2. But because if we are using the seal function, so we'll say math dot, also we need to pull it from the math library. So we say math dot seal, and then we pass in length, which we know is 2.2, and then we run it. We get 3. 2.2, which means 2.2 gets rounded up to the next integer, to the next whole number. So Now if we're getting the seal of h, which we know is already a whole number, 23, we will still just get h. So that's how C works. It returns to you either it returns to you the smallest integer that is either equal to the number you initially had or greater than it. So that's the C function. It either rounds up if you are dealing with a floating point number, or returns to you the same number you had if you started with an integer. So that's the seal. Now after C we have like another function which is like opposite to seal, which is the floor, which always rounds down. It does the same thing like seal, but like it's opposite to seal. It's almost like the seal, it rounds but in the opposite direction. That means it always rounds down. It doesn't matter if after our decimal place the number we are trying to round up is a 9 or something. For example, if we are going to change the length variable to 2.9, normally if we are just rounding up without really checking anything, it will be like the tendency is to round this up because it is already greater than 5, like after the decimal place greater than 5. But for when we are rounding, when we call the floor function, it always rounds down. That means it returns the largest number which is not, like for example we're talking about x, it returns the largest number which is not greater than x, which is either equal to x or not greater than the largest number, which is, sorry, let me come again. So the floor method returns the largest number which is not greater than x, like if we're dealing with x, which is not greater than x. That means it returns the largest number that is not greater than the initial number we are dealing with. So in this case we have 2.9. the tendency is it will be rounded down to 2. So to get this, we'll say print again. To use it, we need to pull it from the math library. So we say floor. So we can clearly see that length is 2.9, but if we should pass it through a floor method, what we get is we get a 2. That means it gets rounded down. So that's how the floor function works. So if we were to do it for 23, we'll just get 23. So again, it works like the seal function. If the starting number is a whole number, it returns the same number. But if the starting number is a floating point number, we round down for floor and we round up for seal. So the next built-in function we are going to look at is round, like so. So the way this works is, this is similar to seal and floor with some slight differences. We saw that seal always rounds up if it's dealing with a floating point number or returns the same number, and with floor it always rounds down or returns the same number. It always rounds down if it's dealing with a floating point number. But with round, we see that it takes certain things into consideration before rounding, either up or down. So for example, we say print, and let's say round, we don't need to bring, like, we don't need to it's not exported from the math library. So round, so for example we want to round up length, so let's just change this length. Let's say it was like that. So the round function takes the variable it is looking to, that we want to round up. So we pass in the variable that we want to round up, up or down, and then it takes a second optional parameter which indicates the point at which we are looking to round up or down. For example, if you are looking to round up to 1 decimal place, we pass 1 there. If you are looking to round up to 2 decimal place, we pass 2 there. So for example, if we are looking to round up to 1 decimal place, you see that length is 2.5231, and when we are at the first decimal place where we are looking to round up, when we check the next number that comes after that, we see that the number is less than 5, like the number is 5 and below, that is less than 5. And so rounding up at the first decimal place, if we just the like from the first decimal place going forward, like after that point, the rest of the number will just be dropped. The rest of the number will just be dropped. So if we were to run our code, we'll see that we get 2.5. We get 2.5. That means the rest of the number is dropped. But if at this same point we had maybe a 7, we will now see that okay, the number the rest of the number will be converted to a 1 and added to the number at the point we are looking to, at the decimal point we are looking to round up at. We are looking to round up, or round up at. So now that, because we have 7, like that means the number immediately after, like the number after the decimal point we are looking to round up, if like in this case we are seeing 7, which is greater than 5. Now if we run it, we see that it is rounded up to 2.6. so the round function is kind of works like it's in between the ceiling and floor. So it checks certain conditions before rounding either up or down, depending on the value that the value that comes after the point we are looking to round up or down at. So that's the round function. And then after, like the next built-in function we are going to look at is there are so many, we are not going to look at all of them, but I think we'll just look at this one and then another one, and I'm going to add a link in the description where you can check other ones and see how to use them. So the next one we are going to look at is mean, like so. So all it does is it takes a sequence of numbers and returns the smallest one of them, the smallest of those numbers. For example, print, if we had let's say we want math dot sorry, we don't need to mean. So if we had 1, 10, 2, 67, if we have if we had this, so what mean does is always returns the smallest number. And now let me make this 100, because let's so it's not the first number. So what mean does is it always returns the smallest number in a sequence of numbers. When given a sequence of numbers, it returns the smallest number among all of them. So for example, if we run our code, we see that we get 2, and looking at it, we see we get 2, and looking at these numbers, we have 120, 267. 2 is the smallest number. So that's how the mean function works. And the opposite the other one we are going to look at, which is direct opposite of the mean function, is the max function, which always returns the largest number in a sequence of numbers. So if we pass these numbers to the max function and we run our code, we see it returns to us 100, which is the largest number. And one thing I would like to point out is that these numbers can be in a list. This can be a list, so you can pass a list to this function, to min or max function, and it will behave the same like we just passed it, just having a sequence of numbers. So it still works the same if we pass a list. So what it does is it returns the max number if it's for the max function, and returns the minimum number, like that's the smallest number for the min function. So there are so many functions, square root, log, and that there are so many. So when you click dot on math, you see, like in your VS Code, you are able to see all of them. You see, you get arcos, like you can check all of them and see how they work. So we have just looked at this few. So these are some of the built-in functions we can use with numbers. So these are numbers. So I'm going to add a link in the description you can use to look at other math function, built-in functions that you can use to do different things.